Okay, so we've got three more problems from our 3.1 part 2 that we need to go over today. And then once we finish that, you can start on the homework assignment for all of 3.1. So if you're watching from home, we're all jealous of you. Not really. But I posted the assignment in your Google Classroom. If you want to use Cami to write on top of that sheet, you can. If you want to print out those papers and work it by hand, you can. If you want to fill it all out in a Google Doc or just on your own blank sheet of paper, whatever you want to do, just however you would like to work the problems. And then be ready to turn them in by Monday. We may actually grade them in class on Friday if everybody's finished by then. But if not, definitely by Monday. So here's our first question. Sandra wants to enclose a rectangular garden with 200 yards of fencing. What dimensions for the garden will maximize its area? So again, we know we're supposed to be working with parabolas, which are formed when a variable is raised to the second power. So first things, I'm just kind of thinking through what all I have available to me. I know the shape is a rectangle, and I know I'm dealing with its area. So whenever I have a rectangle, right, I have some length and some width. Now, it doesn't tell me what either one of those are in this problem, but I know to find the area, and that's what I'm dealing with, area, I want to multiply the length times the width. Now, that's good and all, but this is not form a parabola because I have three unknowns. I don't know the area, I don't know the length, and I don't know the width. So for a parabola, we need two unknowns, and we need one of them to be a squared variable. And I have neither one of those things right now. So I'm going to go back to the problem and read and see if I can find anything else. Sandra wants to enclose a rectangular garden with 200 yards of fencing. So there is my key. If I am using 200 yards of fencing, I know that the perimeter of this rectangle has to be 200. Because that's what, if I use 200 yards, that's what perimeter is the distance around the outside. Now, I also know the perimeter formula for a rectangle is length plus width plus length plus width, which we can write as 2 lengths plus 2 widths. Now, we're just adding the four sides together to get the perimeter. Now, since I know the perimeter is 200, I can plug in 200 for P. So that's 200 is equal to 2 times the length plus 2 times the width. Now I have a formula with only two unknowns. I don't know the length and I don't know the width, but I can solve for one of them in terms of the other one. So what I'm going to do is I'm going to solve for the length. So I'm going to get the width by itself. So let me say that back. I'm going to solve for the width. So that's going to be 200 minus 2 times the length equals 2 times the width. And then if I divide everything by 2, that tells me the width is equal to 100 minus the length. So now I know what the width is in terms of the length, so I could plug that in for the length in my area formula. And I would want to do that because now instead of having length and width, I'm just going to have width, a W, in both parts of that formula. So that's going to be A equals, and instead of L, I plugged it in the wrong place. Sorry. Hold on, I'm losing my mind. That's what W is equal to. I'm crazy. I was doing it right the first, it's whatever. It is a lot of work. So I'm plugging in for W. So area is equal to length times, and instead of width, it's going to be 100 minus the length. Now, I can distribute. That tells me the area is equal to 100L minus L squared, which, if I flip that around, that's going to be a negative L squared plus 100. So the area of this rectangle is going to change by this equation.
Plus 100L.
Yeah, that should be an L, shouldn't it? Thank you. It's going to change by this formula. I know my leading coefficient is negative, so I know I have a downward facing parabola. And what am I wanting to do? I'm wanting to maximize area, so I'm wanting to find the area when it's at its highest point, which would be right there at the vertex. We can find the vertex by using the axis of symmetry formula, which is x equals negative b, which is 100, over 2 times a, which in this case is negative 1. So that's negative 100 divided by negative 2, which is 50. And so in this case, my x value is the length. So I know that the length of this rectangle needs to be 50 units. It does this time, but that's not how it works.
Well, I mean, it said maximize the length, well, there's 4 sides in the rectangle.
Now I know the length is 50, so I'm going to plug that in to this perimeter formula to find the width. So that's going to tell me 200 equals 2 times 50 plus 2 times W. So that's 200 equals 100 plus 2W. When I move the 100 over, I get 100 equals 2W. So the width is equal to 50. So I know the length is 50 and the width is 50. So now, whenever I work a problem like this that does not have restrictions on the rectangle, then the way that we can maximize the area of a rectangle under normal circumstances is to make the area a square. Okay, that is normally how we want to do that. But sometimes there are restrictions where we're not allowed to do that. So I'm looking at your homework. For example, number 5 on the homework when you get there in 3.1 part 2. It says a rectangular playground is to be fenced off and divided in 2 by another fence parallel to one side of the playground. 480 feet of fencing is used. Find the dimensions of the playground that maximize the total enclosed area. So in cases like that, you can't just divide it evenly. That's not how it works. But if it's a normal rectangle and you're wanting to maximize the area, it is a square every time. So you could have just divided by 4 in this case. But you're going to have some that you can't do it that way, that you're going to have to do it this way. Okay, so on this one, flying too fast or slow wastes fuel. For the Spirit of St. Louis, miles per pound of fuel, M, was a function of airspeed, A, in miles per hour, modeled by the formula. So you see here we've got a very ugly quadratic number.
Says use the graph.
Yes. So what we did last year on this is we used graphing calculators, which I can't let you use this year. Wonderful. So,
I was just saying it didn't give us a graph.
right.
It said use the graph.
Right, so what you need to do is if you have a graphing calculator, you can plug this into it. If you don't, we're going to use a graphing tool to do this. So on your Chromebook or on a laptop, if you'll go to Desmos, Desmos, so you can practice putting this in there. And if you're watching on a video, I'm just going to have to upload screenshots of what we did on Desmos because I don't think I have the capability to record my voice and go to a different screen. Let me see.
Go to graphing calculator.
Hello, hello, hello. Okay, so it'll still record my voice when I go to Desmos, but I do not think you can see my screen. Maybe you can. So we're going to Desmos, Desmos.com. Okay, now where's my graphing calculator? So I click Math Tools and then click Graphing Calculator. Okay, and it comes up right there, a place for me to enter. So I'm going to click Functions. Nope, that's not what I'm going to click. Does it automatically just start f of x? No, it doesn't. So we're going to have to put in y equals. Okay, and then in this problem, it's it's negative. So I'm going, where's my negative button?
Does it not show it on the graph?
Negative 0.00065 x squared plus 0.127x minus 5.01. No, that didn't work.
I'm confused because it doesn't show it on the graph.
I got one, so,
You got it
yeah.
Yes, it's because I don't know how to put in a negative right here. It's using that as subtraction. What I need for it to be a negative.
It literally gave me this
I'm
Put it
looking.
in parentheses,
the more I
maybe?
zoom out, the more it bends. Hold on.
I'm going to try putting it in parentheses.
It gave me a parabola now, but I had to zoom out a lot.
Do you have a negative in there?
I have negative y equals negative 0.
How did you get the negative? You just hit the minus button?
Yep.
Okay.
Wait, what?
I hit the minus button and zoomed out a lot. It gave me a parabola.
It is a parabola.
I was just zoomed out a lot.
Yes. So the subtraction button works as a negative in this. Okay, I didn't know if it would. So I've got this parabola. Again, I'm zooming out to where I'm looking at it to negative 1,000 to 1,000. So it says flying too fast or too slow. Miles per pound of fuel, M, was a function of airspeed, A, in miles per hour, multiplied by the formula. So the M is my Y value, which is how many pounds of fuel, and A is the speed in miles per hour. Use the graph to estimate the most economical airspeed. So what X value do I get the best miles per gallon? Well, that's going to be when it reaches its maximum value. So this graph reaches its maximum. So you see I'm zooming in here. It's pretty close to 100. Right, you see where at 100 it reaches its peak. So if I was estimating, I would estimate around 100. So on A part, I'd say it's roughly 100. Now it tells me to use a formula to find the actual value where A maximizes M. So we know that that's going to occur at the vertex. So for B part, we would use the axis of symmetry formula. X equals negative B, so negative 0.127 divided by 2 times A, which is negative 0.000653.
We're looking for the bracket.
Mm-hmm. And so that's 0.127 divided by 2 divided by 0.000653. If we did that, we should get 97.2. 434916.
This just says 4, 3.
Did you just do that in your
No, I use mine. Okay. So you see our estimate was about 100 and it ended up being exactly 97. So we were in the correct ballpark. We got it about correct. That says, how many gallons of fuel did he burn per hour if he flew 97 miles per hour and got 1.2 miles per pound of fuel, which weighed 6.12 pounds per gallon? I hate this question. So I know that my speed, A, is 97. I know that the value M is 1.2 because it tells me M is the miles per pound of fuel. Okay, then the thing I don't know is the weight. So the weight was 6.12 pounds per gallon. I can't even tell what that says. Let me write this neater. Okay, so if I look at these two values, the M being miles per pound, and then this weight is 6.12 pounds per gallon. If I multiply those units together, that's miles per pound, and that's going to be multiplied by pounds per gallon. So if I work that out, that's going to tell me how many miles per gallon that the Spirit of St. Louis got. So I want to multiply 1.2 times 6.12 to find out how many miles per gallon this plane got. So 1.2 times 6.12, which is 7.344 miles per gallon. So this is how many miles per gallon that he got. And he was flying at 97 miles per hour. So I know how many gallons of fuel did he burn per hour? Well, he was going 97 miles per hour, and he was getting 7.34 miles to the gallon. So I would divide those, because that's 97 miles per hour and that would be times the reciprocal would be 1 over 7.344, and this would give me miles per gallon. And you would see my units become gallons per hour, which is what I'm looking for. So I would do 97 divided by 7.344, and I got 13.21. So I got 13.2080. So I round to 13.21. And again, my units are, that's how many gallons per hour, which again is what I was looking for. How many gallons did he burn per hour? So that kind of question, again, is a lot of physics. It's a lot of unit analysis because you're wanting to get specific units to make the problem work. So I didn't actually know exactly what to multiply by what and what to divide by what. I just did my unit analysis. So I knew I was looking for gallons per hour. So I knew from this original I did not need pounds anymore. So once I got rid of the pounds, it became miles per gallon. And then I knew that I did not want miles anymore. I wanted hours. So I took miles per hour and put it with the miles per gallon so I could get hours or gallons per hour in the end. So again, that's a lot of unit analysis, which again is a lead into physics. Okay, so this is one that's very easy to mess up on. So I'm going to take my time here, make sure I get it correct the first time. A lady wants to make an open top box for packing baked goods by cutting equal squares from each corner of a 10-inch by 16-inch piece of cardboard. So that's what I'm starting with in this diagram. This whole piece of cardboard is 10 by 16. But she figures for versatility, the area of the bottom must be 80 square inches. What size does she cut from each corner? So you see, she's cut out a little square in each corner of this box, so it will fold up so it looks like this. And so we want to know how much did she cut from each corner. So this one tells me, because they've got the answer put in here, we should get 3.179. That way if I mess up, I will know that I've done that. So let's start by thinking about what is the area of the entire cardboard before anything is cut.
160.
Yes. So the area before we cut anything out can be found by 16 inches times 10 inches, which would be 160 square inches. Okay? Now, the way that I like to go about it is I like to find the area of each individual piece here, because I know that this piece plus this one 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 should be 160, because that's the original cardboard cutout. Now it tells us, she figures for versatility the area of the bottom must be 80 square inches. So I want this middle piece here to be 80 square inches. Now, this little piece that she cut out, it tells me it's X by X. That's the value we're looking for. How much did she cut out? So that little piece that's missing, the area of it could be found by doing X times X, which is X squared. And it turns out she's cut that same amount off of each one of these pieces, so each one would be X squared. Okay, now let's look at the sides. So this side length here used to be completely 16 inches, but we took off X here and we took off x here. So it was 16 in total, but we lost 2 x's. Whatever that value was, we're subtracting it twice. So the length of this piece, so let me draw that out here. So the length of this piece would be 16 minus 2x. And then the width of this piece is going to be x. So to find the area, we would just multiply that. So that would be, and again distribute, negative 2x squared plus 16x. And the same would be true for this bottom piece. It would be negative 2x squared plus 16x. Now when we look at the side pieces, again, it's very similar. Okay, so it used to be 10 across, but then we lost 2 x's. So that's going to be 10 minus 2x. And the width here, again, would just be x that we have lost. So when I distribute that, that's going to give me negative 2x squared plus 10x for this piece, and also for this piece. So negative 2x squared plus 10x. And so then what I like to do is I like to add all of those together, because I know when I add all of that, I should get 160. So that's going to be x squared plus x squared plus x squared plus x squared. That is 4x squared. Then plus, I've got negative 2x squared plus 16x plus negative 2x squared plus 16x. So that's these pieces. Now I've got these pieces, the green ones to deal with. So that would be plus negative 2x squared plus 10x. And then again, negative 2x squared plus 10x. Why would that not tie in there? Okay, so I've got 1, 2, 3, 4, 5, 6, 7, 8. And then the ninth piece is that center, which we know is 80. And I know if I add all that together, I should get 160. So I'm going to set that equal to 160. And now we're going to group our like terms. Okay, so 4x squared minus 2x squared minus 2x squared, that all cancels. And I'm left with minus 2x squared minus 2x squared, which is negative 4x squared. Okay, then I've got a 16x plus a 16x, that's 32x, plus 10x is 42x, plus 10x is 52x. So negative 4x squared plus 52x. And now then I had an 80, I'm going to move the 160 over to the same side, make it negative. So 80 minus 160 is negative 80. Okay, and I'm wanting to know the x values that make this 0, that makes it all balance out. So what I'm looking for then are the x-intercepts. So I could use factoring, but I can just tell by looking I don't want to factor that. So what I want to do then is use the quadratic formula. So I'm going to plug in x equals negative b plus or minus square root of b squared minus 4 times a times c all over 2 times a.
That number.
Ugly number?
Yeah.
So make it into a decimal.
11.2169.
Okay, so that was with the plus, right?
That was with the minus. And the plus is 1.78300.
So what was one with the minus? Was it negative or positive?
Hold back a minute. The minus was still positive. It was 11.2169.
Okay. 11.21. So I've got two possibilities here. So the little piece you could have cut off could have been 11.21 or 1.783. Okay, well, it can't be this one because the side here was only 10 inches to start with. So she can't cut off 11 inches from both sides because we wouldn't have any piece left here. So this number doesn't make any sense. So that means this must be my x value, 1.783.
If you squared, it's 3.175.
Correct, which is what we're looking for. Because, again, it doesn't ask me how much did she cut off. It asks for the area that she cut from each corner. So if this was an x by x, then I would multiply 1.783 times 1.783 to give me 3.179 square inches.